from the beautiful Treasure Coast of Florida. You're watching Ham Radio Concepts.
Hey guys, it's Ham Radio Concepts. This is Eric, and this is the MFJ-269c. Let's go ahead and take a look at this, touch on a couple points, and then we'll show it in action. I recently got to see MFJ at the Orlando Hamcation. Very nice people, actually getting to meet them at the booth, and picked me up an analyzer here. This is the brand new model that they have, and it does HF all the way through UHF, even the 220 and the UHF band. It goes from 0.53 kilohertz all the way to, I think, 480 megahertz. So you can cover everything in all your ham bands. This is much more than just an analyzer, so we'll show a few things on here in action and show you exactly what it does. And this came with a N to SO239 adapter, okay? And what you'll see here, I'll touch on this first. Most importantly, if you want to know something very cool, MFJ actually uses their analyzers in their factory when they're tuning and building their radios and antennas. They use their own analyzer. They're not giving somebody else the credit of buying some $4,000 analyzer and then selling you this. They stand behind it, telling you that they're so confident in this that they're going to use it themselves. And MFJ analyzers are really a good thing to have. So your power button is recessed in here so that it doesn't accidentally get busted off, okay? Your LCD screen here and liquid crystal, the screen. This shows your SWR as well as on a analog meter. Your reactance, your resistance, and the frequency that you're sweeping, as well as coax loss and some inductance and capacitance values. Your knob down here, this is your tune knob. This is, I'll show you here, we'll turn it on. Okay, and it's going to run a self-test, shows you the version, the voltage, and what mode you're in. Okay, now this number represents the number that you're sweeping. So you would set the appropriate band here. If you want to be in 2 meters, you would set it for UHF low, and that'll give you the range of 113 to 155. Now you can sweep with this knob from 113 to 155. All right. If you need to go down to 10 meters, you simply switch here to, there you go, there's 11 meters, 10 meters, all right? And as you're sweeping with an antenna connected, I'll show you in a minute, it'll show you your SWR as you sweep. So you can find the dip, the lowest null in SWR, the dip they call it, as you have your antenna connected, and the impedance of that value as well. And again, it will show you your SWR on here in a digital form. Okay, and it will also show you your resistance and your reactance. And of course, this says maxed out because there's nothing connected to it. Your modes, this is your SWR mode. You have a coax loss mode, shows you your loss in dB. Your capacitance in picofarads. Your inductance in microhenries. Okay, and a frequency counter. So let's see on the top here. You have your antenna connector, which is an N connector, okay, and that's why they came with the adapter N to SO239, or if you're using UHF, you can put the N right on there. This is a ground, okay, your frequency counter input. Do not apply more than 5 volts of any kind of DC voltage, more than 5 volts DC here, peak to peak, I think they said. Basically, if you're not sure how you're going to inject for a frequency counter, read the manual. It's very important. A standard DC power jack. Now this analyzer takes 10 AA batteries. When you take this cover off here, there's 10 AA batteries. All right. My recommendation is to use nickel metal hydride rechargeable, and then you can plug the power adapter in, and it will charge the batteries up. You do not want to put batteries in here that are not rechargeable and then plug it in. You're going to have a bad problem there, okay? So anyways, solid metal construction with the rubber feet pad in the back so you can put it down, okay? And a lot of other things you can do for calculating inductance for a certain network. There's even a dip meter kit that I have in the other room that will turn this into a dip meter. so that you would connect it with a coil here, and the ground is here. And if you're into, I am not going to be demonstrating that or using that, but it's very possible on this antenna analyzer, not just sweeping SWR, but testing coax lengths, velocity factors, and stuff like that. So let's go ahead and get outside, and I want to test a couple antennas with this and show you how it works. All right, so we got this on the good old 10-meter mobile antenna again that I had made. And you've seen in a previous video with my other analyzer that I had that thing right in the center of the sideband portion of the band at 1:1. And that's what we're seeing here. 50 resistance, 50 ohms on the impedance dial there, 1.1 SWR, and the reactance is 5. Closest to 0 at the reactance, and a perfect match would be resistance 50, ohms, impedance 50, and reactance 0. And then, you know, you take this knob and you can sweep up, and you see the frequency increasing, and the SWR is going up because the sweet spot is, and that's not even that bad. I can work all the way into FM with this antenna at 1.4. That's very acceptable. Go back down here to where I was at, 440 right there, and that's looking good there. So I'm up here on the roof testing my vertical dual band VHF UHF vertical, and I recently found with this that I have a coax problem, because up here almost at the feed point I'm 50 ohms, 1.5, 1.6 somewhere to SWR. Okay, down in the shack is showing me 4. So I go up here to the center of the band. 1.46. Well, I mean the center of the simplex here. 1.4 to 1. But, you know, I'm not happy with these readings because I want to troubleshoot this antenna. It used to be a lot better than this. You know, you get some stuff up here in the, you know, condensation. This is a tram antenna. I wasn't really happy with it when I bought it, but it worked quite well for a $40 tram antenna I bought on Amazon. But you know, let's go to UHF here. That's the cool thing about this analyzer, is it has UHF. So UHF doesn't do the ohms. It only shows you the SWR, but it's showing me basically 1.8 is the lowest it's got, and that's way down in the lower portion of the band, not even where the repeaters are. So, you know, something's definitely not right with this antenna, and this is why it's a good reason to have that. 1.8 to 1 is the lowest it's going. So this is a very cool thing to use analyzers for. Now I can start doing sweeps of antennas, you know, different antennas that come on radios, and see which one really makes, which one's the most resonant, or which one has the lowest SWR. This is the antenna off of my Yaesu Fusion handheld, and you'll see here that it's 1.0 right there, 50 ohms at the center of 2 meters right there. Okay, and let's see, 1.1, you know, but you can see exactly where it is. Now keep in mind, with a handheld antenna, your body in the radio acts like a counterpoise, so it's hard to get an exact reading. Me simply putting my hand on the analyzer like this, you can see is raising the impedance. See? But you can get an idea that, of course, you'll see here if I go up to 150 what the SWR is. Okay? So you can kind of dial it in and see, alright, I have right there 1.1 at just about the center. Alright, and then we'll go to UHF. We'll go up here to where the repeaters are. Now UHF it's not so good on that antenna. Alright. Let's do another antenna. Now look at this. This is the antenna off of my ID51 Icom D-Star handheld. Alright. Look at that. Center of the band, 4 to 1 SWR. Okay. Look where the dip is. Way up toward the top of the band. It's not even really a dip. 1.5 is about the lowest I'll get. Alright. Look, even 145, 400 is the repeater. Locally, you know, when you're dealing with 4 watts or 5 watts with a handheld in a mobile environment, every little bit of dB counts, and signal, you're losing it all on that one. So Icom antenna not so well. And what I have on here is my N to SMA adapter on the top here. Let's put the ASIM antenna back on. Alright. What do we have here? Look at that. Yaesu outperforms again. I'm a Yaesu guy, so I wouldn't be surprised Yaesu came out with a better antenna for a handheld than Icom did. Right there. They tuned that thing right in the middle of the band. Alright. So there you go. Analyzers are cool. This one is very cool. Oh, let me show you what else is cool. My MFJ carrying bag for it. This and the strap case here has the pouch in the back. What you could do is put this in there, take the knobs off. There's holes in here to put the knobs through, and keeps your analyzer nice and safe. So thanks for watching, and check out my other videos on all these cool little gadgets here. 7-3 from KJ4YZI.